Good day, students. In this clip, we're going to be going over some examples on how to solve logarithmic and exponential equations. So let's go ahead and write down instructions for problems 1 to 5 and to solve each equation. Okay? All right. So problem number 1, we're going to solve the equation 5 to the 2x minus 3 equals 0. All right? Okay, so how do we solve something like this? The ultimate goal is to isolate x. So let's do this systematically. We're going to get rid of this, move over this negative 3, and then get rid of the 5, and then finally the 2, okay? So I move this negative 3 to the other side. We can add 3 to both sides. So that'll yield 5 to the 2x equals 3. Now to get rid of this 5, we're going to take log base 5 of both sides. So basically we're going to have on the left side log base 5 and also on the right side log base 5. Log base 5 of 5 to the 2x on the left, and then on the right log base 5 of 3. The reason why we selected log base 5 is because the base of this exponential expression is 5, alright? So with this setup right here, log base 5 was 5. These two are inverse operations, log base 5 and 5 to the exponent, so these cancel out. So we're going to have 2x equals log base 5 of 3. And then to finally isolate 5, you divide both sides by 2. And you'll be left with x equals log base 5 of 3 divided by 2. Alright, so there goes your final result. Alright, let's move on to question number 2. So for problem 2, we're going to solve the equation 5 minus the natural logarithm of y plus 3 equals the natural logarithm of x plus 2 minus the natural logarithm of 2. Okay? Alright, so first of all, we want to place all the terms with the natural logarithm on one side of the equation, consolidate them using the properties of logarithm, and then eliminate, and then see how we can isolate the y. Okay? Alright, so to do that, this negative natural logarithm of y plus 3, we're going to add it to both sides. So we're going to have, let me just show you what I'm doing here. Add natural logarithm of y plus 3 to both sides. Okay. Alright, and that's going to yield 5 equals the natural logarithm of x plus 2. Let me bring the plus here, plus the natural logarithm of y plus 3 minus the natural logarithm of 2. Alright? Okay, now we're going to consolidate or condense this logarithmic expressions here using the properties of logarithm, okay? So we know that the sum of logarithms is the same thing as the product of the arguments of the logarithmic sum, and then the difference is the same thing as a quotient. So this entire expression can be written as the natural logarithm of, since these two will be multiplied by each other, we can write it as x plus 2 times y plus 3, and then this minus is division, so divided by 2. Okay, so this is a condensed form of this logarithmic expression right here. Okay, now remember our goal is to isolate y, so we have to get rid of this outermost function so that we can get rid of x plus 2, and then finally this 3 right here. So the inverse of natural logarithm is e. So we're going to exponentiate both sides using e as the base, okay? So on the left side, put a big E, and on the right side, big E. We're going to exponentiate the left side of the equation, so it's going to be e to the 5th power, and on the right side is going to be e to the natural logarithm of x plus 2 times y plus 3 over 2, like that, okay? On the right side, the e and the natural logarithm are inverses, so they cancel out. So we're going to be left with e to the 5th equals x plus 2 times y plus 3 in this whole expression over 2. Okay? All right. Now, to get, we're going to start isolating y plus 3 this expression. So first thing to do, multiply both sides by 2. So multiply by 2. And then we have 2e to the 5th equals x plus 2 times y plus 3. All right, this 2 is divide out. And then we divide both sides by x plus 2, x plus 2, and x plus 2. That divides out. So we're left with y plus 3 equals 2e to the 5th over x plus 2. And then to finish this off, we just simply subtract 3 from both sides of the equation. And then our final answer, y, is going to be equal to 2e to the 5th over x plus 2 minus 3. Alright, so there goes your final result. Alright, now we're going to move on to question 3. We're going to solve the following equation. What if we had the equation 4 to the x minus 2 equals 8 times 4 to the negative x. Alright, so how do we solve an equation like this? So first thing we're going to do is use the properties of exponent to rewrite this negative component right here. So what is 4 to the negative x is the property of exponent. So it's going to be on the left side. The left side stays the same. 4 to the x minus 2 equals, now using the reciprocal property of exponents, this is the same thing as 8 over 4 to the x. Okay, anytime you have a negative exponent attached to a term, you can reciprocate that term and do the opposite of the exponent. Alright, so there we have it. Now what we're going to do next, we're going to attempt to eliminate this 4 to the x in the denominator on the right side right here. So to accomplish that, we just simply multiply the entire equation by 4 to the x. Okay? Alright, so let's do that. So here we'll distribute 4 to the x to every single term. So here we have 4 to the x times 4 to the x minus 2 times 4 to the x equals, and then 8 times 4 to the x, there's going to be cancellation happening. These two cancel out, so you're just going to be left with 8. Okay? Alright, so now let's see. We have 4 to the x times 4 to the x here, so we just simply add the exponents. X plus x is 2x. So we're going to have 4 to the 2x minus 2 times 4 to the x. Now we can subtract 8 from both sides. So we have minus 8 equals 0. So we're going to have it in this form. Okay? So if we note that this can actually be written as a quadratic equation. Alright? So how can we do that? Well, check this out. Okay, right? It says 4 to the x quantity squared. Okay, because 2 times x is the same thing as that. Minus 2 times 4 to the x minus 8 equals 0. Okay? So they have a quadratic equation. To make it obvious that this is a quadratic equation, let's make a substitution, and then when we're done factoring, we can put back our values. Okay, so how about say let's use u, let u be 4 to the x. Okay, so if u is 4 to the x, what is that? How does that affect our equation? So our equation is going to look like u squared minus 2u minus 8 equals 0. So here we can clearly see that this is a quadratic equation. Now let's factor this, solve, and then plug this back in to finish up the problem. Alright, so we're going to make a little x here. AC is negative 8 and B is negative 2. The two numbers that makes this factorable. We're going to use 4 and 2. 4 times 2. So since the sum is negative, we'll put a minus in front of the bigger number. If that works. All right, so we're going to have u squared minus 4u plus 2u minus 8 equals 0. So let's factor this. Factor out u. We have u minus 4 plus 2u minus 4 here also equals 0. So we have u minus 4 times u plus 2 equals 0. All right, so let's keep on solving. So if we want to solve this using the zero product property, we have u minus 4 equals 0 and u plus 2 equals 0. If I solve this, I'll have u equals 4 by adding 4 to both sides, and u equals negative 2. All right, remember earlier we said that let u be well, let's say that u be 4 to the x. Okay, so let's put that back in here. So we're gonna have 4 to the x equals 4, and then here we have 4 to the x equals negative 2. All right, so let's go ahead and solve these two. If we take a look at the equation to the left, since 4 is the base here, we're going to take log base 4 of both sides of the equation, log base 4 on the left and log base 4 on the right. So we're going to take log base 4 of 4 to the x equals log base 4 of 4. On the left side, log base 4 and 4 cancel out, so you have x equals log base 4 of 4 is simply 1. Okay? Because imagine this is 4 to the first power. These two cancel out, we're left with 1. Same story here. We're going to take log base 4 of both sides of the equation, log base 4 and log base 4. On the left side is log base 4 of 4 to the x. On the right side, I have negative 2. Okay? This cancel out, and we have x, and logarithms cannot take in negative input. Negative inputs or arguments are not in the domain of log base f, log base n, so this is undefined. So the only answer that we have is x equals 1. All right, so there goes our final result. All right, let's shift our attention to question number 4. So for question 4, what if we're going to solve the equation 1/3 of 3 to the 2y equals 4 to the negative y. Okay, so we can clearly see this problem here. We have y's in both sides of the equation, so we're going to have to fix that one way or the other. All right, so first thing we're going to do is we're going to use the reciprocal property of our exponents to address this negativity in the exponent on the term on the right side. So this expression is going to become, and then also we have a 1/3 in front of this number right here that we have to address very soon. So let's write this as 3 to the 2y over 3 equals, now we reciprocate this because of the negative sign in front of the exponent, equals 1 over 4y. Okay, 1 over 4 to the y, sorry. Okay, so we can just simply cross multiply here. If we cross multiply, we're going to have 3 to the 2y multiplied by 4 to the y equals 3. Okay? All right, now if you notice, these two terms are being raised to the y. So we use the reverse of the power of product of powers property. We can factor out this common term in the powers, and this term can be written as 3 squared times 4 raised to the y power equals 3. Okay? Now 3 squared is 9, 9 times 4 is 36, so we have 36 to the y power equals 3. And then to finish this off, we just basically divide both sides by 36. Actually, no, I'm sorry, I can't do that. This is an exponent, so what we have is we're going to take log base 36 of both sides, okay? So we have log base 36 on the left and log base 36 on the right, because the base of this exponential expression is 36, okay? So log base 36 on the left side of 36 to the y equals log base 36 of 3 on the right, okay? And then these cancel out, and we have y equals log base 36 of 3. And if you want to use change of base formula, you can also express this as the natural logarithm of the numerator of the base of the of the argument of the logarithmic expression divided by the natural logarithm of the base, which is 36. So these two mean exactly the same thing. Two ways of writing the same answer, all right? So that is the value of y. All right, let's take a look at the last problem, question number 5. So the task here is to solve for y in the equation log base 2 of x to the third plus log base 2 of x minus 3 plus 3 equals log base 2 of 2 minus y plus x to the third plus log base 2 of 5. Okay? Alright, so what we can do here is we can collect all the terms with the log base 2 to one side of the equation and then condense them using the properties of logarithms and then have everything else on the right side. So remember the goal here, I'm on the other side. So remember the goal here is to isolate y. Okay, so let's keep that in mind. So all the terms with the logarithmic term associated with it, let's put it on the left side of the equation. Okay, so we just have log base 2 of x to the third plus log base 2 of x minus 3. Now we have to subtract log base 2 of 2 minus y from both sides, so minus log base 2 of 2 minus y. And this term also subtracted from both sides, so you have log base 2 of 5 equals x to the third stays on the right, and we subtract 3 from both sides, so we have negative 3 on the right side also. Now we're going to condense these logarithmic terms on the left side using the properties of logarithm. Okay? Alright, so let's go ahead and do that. So anytime you have, if you have a sum, that's a product, and then if you have a difference, that's a quotient. Alright, so we can see here, we have a sum. So this first term is going to be multiplied by this, and then you have two minuses here, which indicates division. So we're going to divide this first term by these other two terms here. So this is going to be written as log base 2 of x to the third. So this plus this becomes a times x minus 3 divided by those other two terms, quantities, 2 minus y and 5, because you have that minus in front of those two logarithmic terms. Okay, so that and that will be equal to x to the third minus 3. Okay, x to the third minus 3. All right, now to get rid of the logarithmic, the log, we're going to use its inverse, which is exponent. So we're going to exponentiate both sides using 2 as a basis of exponentiation. So what we're going to have is a big 2 on both sides. So we'll have a big 2 on the right, on the left, and then a big 2 on the right. And then we're gonna have a little log base 2 of x to the third times x minus 3 over 2 minus y times 5 on the left side equals 2 to the x to the third minus 3. Okay? Alright, so on the left side this cancels out. So we're going to be left with the expression. The expression is going to be x to the third times x minus 3 over 2 minus y times 5 equals 2 to the x to the third minus 3. Okay, so this is basically like the exponent of the 2 right there. All right, so now what we're going to do next, we can cross multiply, and then that's going to yield x to the third times x minus 3 equals 2 raised to the x to the third minus 3. That times 2 minus y times 5. Okay? So remember, we want to isolate y, so what we can do is we can divide both sides by these two terms. So divide the left side by 2 raised to the x to the third minus 3 times 5. Okay? So let's put it here as 5 times 2 raised to the x to the third minus 3. So this divides out. Okay, and then we're going to have 2 minus y equals x to the third times x minus 3 over 5 times 2 to the x to the third minus 3. And then we can add 2 to both sides and then multiply by negative 1, and that will finish the problem up for us, okay? So to do that, just actually subtract 2 from both sides. If you subtract 2 from both sides, we have negative y equals x to the third times x minus 3 over 5 times 2 to the x to the third minus 3 minus 2. And if we multiply both sides by negative 1, we'll have the final result, which is going to be 2 minus x to the third times x minus 3 over 5 times 2 to the x to the third minus 3. Okay? So what I did here is if you multiply by negative both sides, this term becomes negative, this becomes positive. You just switch it around, and there goes your final result. Okay? So there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here so you can get updates to future clips for calculus such as this. And please post a comment to let me know what you think about this presentation. More clips can be found on calculusserve.com. Thanks again for watching and have a wonderful day.